My name used to be Hernan Wilkinson, but yesterday I've been renamed, and now I'm Will Clippy. So thank you, Nico, for that. So, okay, I'm Hernan Wilkinson. I'm one of the founders of 10 Pines. I'm also a professor at the University of Buenos Aires, and I'm going to talk about LiveTyping. So before I start, I'd like to know something from you. So, is Smalltalk cool or what? What do you think? Yeah? I cannot hear you. Is it cool or not? Yes, of course it's cool. Yeah. But why? Why is it cool? What do you think? What? Short feedback. That's axiomatic. Syntax. Okay, there are many features we love about Smalltalk, but for sure you will be with me when I say that it's because it's a dynamically typed language. That's one reason, too. Yeah? And because it's a live environment. Yeah? We have short feedback loops, and we can do everything as fast as we want. But sometimes when looking for senders, even though it's a dynamic and live environment, looking for senders is done statically. And we got more senders that we want, and we have to manually filter them. When we look for implementers, we have the same problem. We have to manually filter the implementers we got and to fit the right ones that we're looking for. What about refactoring? Renaming a message, we have the same problem because it's based on senders and implementers. What about the autocomplete? The autocomplete in the browser is done statically. Of course, we can do some type inference and those kind of things, but they are not very, sometimes they work, sometimes they doesn't. So, and so on. So yeah, Smalltalk is cool. Yeah, because it's dynamically typed, because it's a live environment, but so can we get rid of this bad? Aren't you tired of having all these problems when you're programming, or you just got used to them? So I got tired, yes, and I think it was time to act and do something different. So what if we combine this idea of dynamically typed languages with the fact that Smalltalk is a live environment, and we create a tool to automatically annotate the types of the objects we have, and we improve the tools based on that information. Yeah, what about that? So what's LiveTyping? Well, it's that. Okay, it's an automatic type annotation VM, okay, with some improvements to the tools that we use all the time. The annotation of the types happens while the system runs. So I modified the VM 5 or 4 bytecodes, I don't remember. So every time an object is assigned to a variable, I keep the type of the object that is assigned in an array of n number of elements. The same when a method is executed, and the same for the method returns. So as you know, for sure, you're thinking, but that's not new. This is all. A lot of people thought about it, and you're right. This is not a new idea. Yes, I mean, it goes back to 1986. These papers of Dan Ingalls about multiple polymorphism. He talks about, hey, why don't we do something with the types? Yeah, and then we can talk about David Ungar on polymorphic inline cache. He mentions that in that paper in 1991, if I'm not wrong. Yeah, or we can talk about Marcus' paper about gradual typing in Smalltalk. Great paper about that too. So this is not a new idea. Yes, I'm not claiming that, but it's a particular one and it works. It's working. So something to be aware of is live typing is not about doing type checking as normally all the other languages are doing at this time. Yeah, with JavaScript you have TypeScript because they want to type check. That's the only reason they do it. With Ruby, they have now something I don't remember the name, and the idea is to annotate types in the source code to type check. Yeah? So type checking for me is not the most important thing of live typing. The idea, we will have type checking, I'll show that, but the most important thing are the benefits of the other tools that we get when we have type information. So let's go to the examples, the important part. So do you know tic-tac-toe? For sure you do. So I have a tic-tac-toe implementation here. Is the font right? Yeah, I guess so. Okay, this is the class that represents the game, and that's implemented with the state, tic-tac-toe state with a hierarchy of possible states of the game. So what's the first thing we can do with the tool? The first thing that we can do is to see the types of the objects that we have. For example, if I come here and I put the mouse over the variable, it says, okay, player X position is an order collection. The same with player O positions. And the same with the state. But state, in this case, has been assigned instances of playing X, playing O, and so on, and all of them has a super type tic-tac-toe state. You can not only see it as a balloon help, you can press something, and you will get a menu with all the classes, and if you want to browse to the class, you can just press and browse to the class. This works for everything, even any method. So for example, I want to know what position is, so I put the mouse here, position is a point. Or I want to know the return type of this message. It's tic-tac because it's an implicit self. What about if I go to is over? So if I go to is over, it will tell me it's a Boolean, okay? And all this is recollected while the system runs. You may say, well, I developed tic-tac-toe. I know exactly what the types are of this, all this sort of stuff. Yeah, that's true. But what happens if you go and see morph? And then you get things like R1. What is R1? So R1 is something, well, it's too big, the font. It's a rectangle-like morph, type of, yes? Or what is delay time? Well, you may think that delay time is a duration, but it's not. It is a small integer. Yeah.
What is the list below arg1? Can you go to arg1?
Yes.
So yeah, you show a list. Yes. So what is below? What is the difference between rectangle-like morph and allo handle morph?
There are subclasses.
Okay.
In this case, what I'm showing are all the types classes, yeah, that instances of those classes that were assigned to R1, and all of them have in common the common superclass that is rectangle-like morph. Okay, so that's very useful. I'm sorry, but I'm not. I will answer all the questions at the end because I have a lot of things to do, and for sure you have a lot of questions because it happens to me, in Smalltalk's conference, and I won't be able to finish everything. So if you don't mind, I'm sorry. Okay, thank you. I helped tell that to Stefan, but it's Stefan. He intimidated me. So that's one cool thing. So now every time you're looking at code, you can see the types. So even if it's your code or legacy code or whatever, yeah, you can go to the order collection class or the small system dictionary class and see the types. And that's cool because you don't have to do anything because the system collects all the types automatically for you. What about autocompletion? That's something that every time we talk to a Java programmer or statically typed language programmer, say, but the autocompletion dynamic is not good. So yeah, okay, let's see some things. So let's say I have var1 here. It's saying that it has no type because nothing has been run on this test. So if I click the options, we see this is the normal messages you get in this Smalltalk. Some of them are blue because that means that, if you send this message, it's not sure that it's going to answer that message because it's not implemented in object. And those that are in black is because they are implemented in object. But, this is what you get as a normal, autocompletion because it doesn't know the type of var1. Of course, you can start pressing letters and whatever. But what if we run the test and now we see that var1 is a string? So now the autocompletion shows only the messages of string, and I can do these kind of things. I can start looking at the methods. I can see the like a documentation, short documentation that shows not only the name of the message, but also the types of the parameters and the return type. So that's very useful when you have to learn, what is the message expecting as parameters, what does it return, and so on. What about var2? This is another interesting case, very common in dynamically typed languages, not common in statically typed languages, and is the case where you have objects or variables that point to types that are not in the same hierarchy. They are, they share maybe some messages, but they're polymorphic with some messages, but they are not in the same type hierarchy. Like, for example, small integer and date. So what can we see if we use the autocompletion? So what it will do in this case, because they don't share a common super type, it will show me first the messages that are common to those types, in this case, plus, minus, whatever. And in the documentation, it will tell me, okay, if you use it for a timestamp, it's waiting a duration, and it returns a date. If you use it for a small integer, it's waiting whatever, and returns whatever, and so on. But it's not only showing that, it also shows you, the ones that are answered for each of the types, or not all of them, and in this case, in blue. So times is not answered by instances of date, but is answered by instances of small integer. Yes? So it's very helpful. And something interesting to mention here is that having type information in dynamically typed languages makes things a little bit harder than in statically typed languages, because you can have more than one type for a variable, not like in statically typed languages. Okay, what are dynamic types? I took this idea from, I started thinking about this problem for a question John Brani made me last year, and I took the solution from the Marcus paper, and they talk about dynamic types. What are dynamic types? Are types that are that depends on the context where they are used. They are converted to the real type. So, for example, the question that John made me last year is, what about yourself? What's the type of the return type of yourself? At that time, the return type was object. But right now, if you go and see the return type of yourself, is return self. It's a dynamic type. That, it will convert it here to examples, because self in this method is examples. So that's a dynamic type. It's a type that gets converted to the context that is used. So you have that. You have the dynamic type self. You have the dynamic type class, because if we look at the implementation of class, it returns class. But in this context, the receiver is example, so the type of class is not class, but it's example class. And the cool thing about it is that now we can do new. And what's the type of new? Well, that's too many. That's the only implementation of new that is going to use. That's the one in behavior, and that's instance. An instance gets converted, in this case, to example. Okay? So the cool thing is that, for example, in the autocompletion, it knows that the type of class will be example class. So when I see the autocompletion, it will show me first the instance creation methods that are the ones that you really want to use when you're sending a message to a class, and not any, but the ones implemented in that particular class first. So that's what dynamic types are. Yeah, I'm doing fine with the time. Actual implementers, a much better use of the human brain, like Tudor said on Monday. I think he didn't say it for this example, but I took the sentence. What's that? So let's go to the tic-tac-toe example. We have a message here called mark with X at. That's the message that you send to mark with an X at a certain position. So the mark with X at is implemented at tic-tac-toe, and also tic-tac-toe states and all its subclasses. So if you look for implementers of that message, it will show you 5, all the implementers, no matter the type. That's the common implementers tool we have. But if I look for actual implementers of that message, that particular message, it will show me only one in this case because it's on the tic-tac-toe class. But what about this one? This one is being sent to state. State is a tic-tac-toe state and its subclasses. So if I look for the actual implementers of this message, it will only show me 4 that are those related to the state of that, to the type of that variable. Yeah? So from now on, you don't have to filter implementers anymore. You really have the implementers that are related to the messages, to the type of the receiver that you are looking for. And an interesting thing is that this actual implementers is related to the context of where you're looking for. I have this false if true here just to show you that, again, if I look for actual implementers on this context, the receiver itself, self is tic-tac-toe, so it will only show me the implementation of that message. The same thing with actual senders. So we are tired of looking for senders and getting anything. So if we look for sender of mark x add, we can see that here is being sent to an instance of tic-tac-toe, that is the game. Here it's being sent to state and also to tic-tac-toe and so on. And we got 7 senders. But what about, I want to know only the senders of mark with x add to instances of the tic-tac-toe state hierarchy. So if I come here, do actual senders, it will show me only, in this case it's only one, the place where that message is sent to instances of those types. And look at this, it's not highlighting the same message sent in this method because it's not of the same type as state. Yeah? So the receiver itself, so that's why this message sent doesn't count as a message sent to instances of the state hierarchy. Of course, if I look for actual senders of this message sent, it will show me 7 that are all the messages sent to instances of tic-tac-toe. And here, the same method now, it will highlight this one, but not that one. And of course, all the other sends that are in the tests. So, with these actual senders and actual implementers, fake polymorphism is almost gone. And that requires, we're used to see senders as methods, but now we have to start thinking about senders not as methods, but as message sends, really. Because in a method, you can have many messages sent of the same message, but not to the same instances of the types. So what about refactoring? For sure, you are tired of doing a rename and having to manually select implementers as senders. But now we have actual implementers and actual senders. So why don't we use that? So, for example, if I want to rename mark with x add only in the state hierarchy, I can come here, do a rename. Let's say, I don't know, I want to rename it with that. And when I have to select the scope to look for the things to rename, I have actual scope. What's actual scope? It will look for the actual implementers and actual senders. So now it tells me, okay, these are the implementers that I'm going to rename, only the ones on the state hierarchy. And this is the only sender that I will rename. And again, it would only rename this message sent, but not this one. So if I just refactor, well, that is. So only that message sent. Yeah, so it's like working with Java, but better. Thanks. So, of course, this actual scope, the actual scope, you can do it for any kind of refactoring, like add parameter, remove parameter, change the order of the parameters, and so on. Finally, what everybody thinks that is the most important thing, and I don't, but I did it, and it's here, the type checker. Yeah. So have in mind this, with live typing, we can be sure when a variable, when nil is assigned to a variable. It's not something that could happen. We know for sure when that happens. Yes? So that gives us a lot of information. So let's see some examples. So for example here, IV1, a good name, of course, had been assigned with small integers and also with nil. So it tells you, it can be nil. Yeah, IV1 can be nil. Okay. So if I type check this method, of course, it will tell me date not implemented in its small integer and undefined. So I can fix it. Okay, yeah, you're right. So let's send print string that is implemented in both. So the errors go away. And now it tells me, okay, factorial is not implemented in undefined object. Yeah, you're right. Yeah. So I could do if not nil, IV1 factorial. It's gone. So now my method has no type errors. Yes. So doing a type checker for Smalltalk is very cool, but we have to remember that its dynamic spirit makes it difficult to realize when you are casting types. So, for example, we can see a lot of methods written this way. I'm using a temporary variable just to show you the test data, but the idea is that temp1 could be an instance variable, a parameter, a message send, whatever. But so the idea is, oh, I forgot to remove this. Okay, so I have something like this, it works, but if I type check it, it will tell me, hey, plus is not implemented in undefined object. So it's very common to typecast these kind of things, saying, okay, type one, if nil, return, self. And now, if I type check, it will tell me there is no problem, because it realizes that from here to the bottom, nil is not a possible value for temp1. Well, the same things for if nil, the same things for or ands. It's very common to see code like this. All these examples are here because I started using the type check in the current implementations. You can have nested, this, if nil, if not nil, and so on. And of course, is supported, like here. So temp1 could be a small integer or ordered collection or linked list. So if temp1 is of collection, it will send this message and it type checks correctly. And the same with the famous, class of an object and has model. What is has model? So has model is implemented in morph to return false and pluggable morph to return true. So if temp1 can be morph or pluggable morph. So what it does is it looks for the actual implementors of the types of temp1 of has model. It takes and checks the return type. If the return type it is true, it knows that it has to filter with that. If return false, it knows that it has to remove that type, and so on. So in this case, everything type checks correctly. And of course, the same with things like is collection, is numbers, and those ugly stuff. So the nice part of this is the type checker is pretty robust for this kind of code that we don't like to see, but we usually see. Okay, the final example with the type checker, morph. Let's type check morph. Okay, so this is interesting because it really is showing it's showing real errors. For example, owner can be nil, and it's being sent the message first of morph. There are some problems in morph, most of them related with that, and if we go to behavior, and we type check that, we will see other interesting errors. Maybe some of them are not real errors. There are some false positives. But for example, this one, subclasses do is not implemented in behavior, is implemented in class description, meta class. But so why is this message here? Is this message sent here? It should be at least subclass responsibility in behavior. So it shows you those kind of things also. So conclusions. With NoSQL4, we were able to get rid of most of the problems, not all the problems. And the good thing is that you don't have to maintain or do anything. It doesn't bother you with types in the code. It's almost like working as you usually work with Smalltalk, and you have all these for free. So there is a nice saying, for sure you know it, Victor, in his great talk of inventing on a principle. He says that we're used to playing computers. Well, an unknown Smalltalker is used to play mind games with types, because we are always remembering the types of the objects that we're using. And if we don't remember them, we're used to go and look for them and spend time doing that. So now, with LiveTyping, types are explicit, and you don't have to remember them anymore. You have them there for you. So that gives you more time to spend your mind in useful stuff. It's a very simple techniques, and it really improves the programming experience. This is a thing. When you start using it, you don't want to lose it. Yeah, that's at least what happened to me. It doesn't change the syntax. It doesn't stop you from compiling. It doesn't force you to use it. You use it if you want it. And types are not in the source code. Types are stored in real objects, and you can play with them. Like, for example, you can come here and say, okay, what are the types of I will add a new type, string. And now you have a new type, and you didn't have to change the source code. And you can remove, freeze, and so on. So I humbly believe that this at least respects and honors the Smalltalk spirits, this idea of how to implement types. So on Monday, somebody asked me, so what's your goal? Why are you doing this? What's the idea? So I thought about it, and I think my goal is that we should stop thinking on Smalltalk as a dynamically type, and we should start thinking it as a lively type language. And so, we can start answering those functional guys that want types. Yeah, man, you have types. You want types? We have types in Smalltalk, and we can reason and reflect about them, as you do. So as I mentioned, the implementation, I don't have time to explain this in detail, but it's more difficult than doing type checking in statically typed languages in some parts, not all of them, but statistics, for sure you all want to know that. How is the performance hit is 1.4, so it's 40% slower. But as you notice, you can play and work with it without any problems. Nobody notices. And of course, the same image works with a VM that doesn't collect the types. So if you don't want to do that on production, you use the normal VM, and it works as fast as before. Or on the other way around, I mean, if you don't have tests to test your code, so you cannot, when you're in development, annotate types, okay, you can run on production with the VM that annotate types and download that and then upload it into your development environment, and then you will have types. About the size, it's about double, but there are some tricky things that we can make it go down. Future work. So one important thing is to start annotating types on parameters and arguments of closures. Support for generics, that's very important when working with collections, those kind of things. The VM the changes I made are only in the stack VM, so now we have to put that in the zip VM, but that's very difficult. And one thing that you can start thinking of right now, because you have types, for example, we could change the compiler to use that type information, and instead of letting the VM create and initialize peaks, well, maybe we could do that in the compiler for the VM, and then the VM use it or change it as the system continues to grow. So on the image side, well, with the remote typecast to add to the type checker, the type checker is not checking for parameter types at this time. I have to use the type checker infrastructure to make the auto-completion better because, well, no, that doesn't matter. It's too long to explain. And, well, I could use the type checker to warn you about that code. For example, if you're checking for nil, but that variable has never been assigned, nil has never been assigned to that variable, so I could show you a warning and tell you, hey, this if nil doesn't make sense here. And removing a method, we could do a transitive closure when removing a method and tell you, hey, all these messages that are sent in this method that you're removing are not sent in other places too, so you can remove them. So, thanks. I don't know if I have time for questions. Okay.
How difficult would it be to include the assignment as well? Because in your examples, well, when I would read it, I would know its type.
The assignment itself in where? I didn't understand.
When you here temp1, you know that after the assignment temp1 becomes color new, then it is a color.
It is? I'm sorry, I didn't understand.
Wait.
Oh yeah, but this is because of the example. I mean, temp1 could be an instance variable. It could be a return from a message sent, so you cannot statically.
No, okay, but just as you argue that the is collection and is kind of and all those kind of constructs are included.
Yeah.
I ask, how hard would it be to include assignment as well?
Assignment.
Assigning a variable to a certain instance to. Yeah.
Oh, okay. So I understood now. Yeah, I didn't think about it, but yeah, it could be done easily. The same thing with type checking the parameters. It would be the same idea. The only problem with that is sometimes you may assign invalid objects to variables or parameters, so we have to find a way to easily remove those things. Yes, but yeah, that's a good idea. I never thought about it. Right? Thank you. Yeah. It's not hard to do it. It's not hard. So yeah.
Once you showed that there is a slowdown with this logging of types, can you actually pause the logging in case I'm doing some computation and it takes a long time? Can I pause the logging for that time and then continue with it?
Well, right now, yeah, it annotates types or it doesn't. So, I mean, the VM is always annotating types. The types are being annotated in an array of the size of the array is configurable per variable, and you could decide that array to be nil, and in that case, the VM will not assign types to that variable or parameter or whatever. And of course, you can also manually say the return type of these variables are those specific ones, so you don't lose time at runtime annotating type. I'm not sure if I answered your question.
Yeah. Thank you.
Okay.
If I may one more question regarding detection whether there can be nil in a variable or so. In instance variables, if they are not initialized, there can be nil.
That's
of
right.
Course.
So yeah, I'm not.
Detect this?
Yeah, that's something that I'm not check. I mean, the VM is not checking that at this time. Yeah, as we could do something about it, but yeah, I'm not doing that.
Okay, thank you.
You're welcome.
Yes.
Yeah.
I have a small question. When is this coming to Faro?
Yeah, I tried to do it. I had a problem that I talked with Marcus on Monday. because to make this work, I had to add 4 instance variables. I have to add in class description an instance variable called instance variable row types. That's an array of arrays, because that's what is easier for the VM to handle. So that's where the types of the instance variable are stored. So when I try to add this variable in Faro, in class description, it never ends. I tried it again yesterday, and it started eating memory. It went up to 30 gigas, and it didn't stop. So we talked with Marcus on Monday. I have to do it in the bootstrap of the image, and I haven't tried that. But after doing it, I think it will be easy to port what I did in the Stack VM, the open Smalltalk Stack VM, to the Faro Stack VM, if it still works, and that would be it. Yeah. So yeah, I would like to see it also in Faro, because I want people to use it. Yes.
Yeah, easy question that, editing one method can change the type of different classes, right?
Yes.
The influence can spread over. So can you give some warning that this change might break type safety of some other class that I'm watching at?
Say it again. Let me.
If I change this method in this way before accepting it,
Yes.
this code will break type safety of your
Yeah.
different
Okay.
class.
Yeah. I could do a lot of things. There are a lot of things to do, because now we have all this type information. But what currently, every time you change a method, I'm not type checking. I'm not doing anything, and I'm removing all the types from that method, because that's a way to maintain the cache. Because it's really like a cache of types synchronized. So, for example, if I change this method, after that, well, this is not using, no, let's do this. This one. So right now, type 1 is those types. If I save it and I do not run it, types are lost, okay? So, and you have to run to have the types again. So there are a lot of things to think about, and those kind of things, as you mentioned. Yeah, that's right. Yeah.
Okay, thank you.
Welcome. Okay, thank you very much. Thank you.